All right, my math counts people, here we go. We got warm up 2 from the 2017 problem set. Remember, if it's a warm up, you're not supposed to be using calculators for these. Just practicing for that sprint round. All right, how many pieces that are exactly 5 inches long can Sue cut from a string that is 7 feet long? So I'm going to want to change this problem into inches, because that's what I want to divide it by. So 7 feet, where we have 12 inches per foot, that means we can get 84 inches out of 7 feet. So how many times does 5 go into 84 evenly? That would be 16. So we could get 16 pieces from that. Next, how many units away from the origin is the point -3, 4? Now, when we're measuring distance, we go for the shortest distance. So if I'm at -3, 4, -4, that would be this point here. I wouldn't go up then over to measure distance. I would go diagonally to measure the distance. So this is the distance that we're looking for. This is another Pythagorean theorem problem. Because if I look at my horizontal distance of 3 and my vertical distance of 4, I can now find that diagonal distance, which is what I'm looking for. Now, if you know your Pythagorean triples, you know this is a 3, 4, 5 triangle. If you don't know your triples, you would do 3 squared plus 4 squared is equal to c squared. 9 plus 16 equals c squared. 9 plus 16 is 25. And then you would take the square root to undo the squaring. So c, or the distance from that point to the origin, is the square root of 25, which is 5. Next. All right, so for this one, we've got a hexagonal table that is by itself seats 6 people, 1 person at each side. So if I've got a hexagonal table, I can fit 1 person per side. A row of hexagonal tables is created by pushing together a certain number of hexagonal tables so that the side of one table meets the side of the next table. Okay, so this table meets this table. Now somebody can't sit there. Okay, so nobody can sit there once we put a new table in. Unless you want to be crushed, which you probably don't. Yeah. So in this way, so we're going to keep on adding tables. If 50 people are sitting at the tables, how many tables are in the row? Okay, this one you can kind of almost do a table of values and derive an equation from it. So for instance, if I have one table, so there's just one table right there, 6 people can sit at that table. If I have 2 tables, all right, so if I just had these 2 tables, let's count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 people could sit there. If I had 3 tables, so those 3 right there, start at the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 people. Do you see the pattern yet? It looks like we're increasing by 4 every time we add a table. 4th table. That's all these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And yes, we are increasing by 4 each time. So what we can do really quickly is just write an equation for this one. I know that it's linear because it's adding 4 each time. And then I would need the 0th term. If I'm adding 4 going this way, to get the y-intercept or the 0th term, I would subtract 4, and my y-intercept would be 2. So here's my equation, where x is the tables and y is the number of people sitting at the tables. We would get 4x plus 12. Watch, it works. If I plug in 1, I get 4 plus 2 is 6. If I plug in 2, I get 8 plus 2 is 10. If I plug in 3, 12 plus 2 is 14. So there's my equation. And now I have 50 people. People is y. x's tables. So I'm just going to write 50 equals 4x plus 2. Subtract 2 from both sides, I get 48 equals 4x. Divide by 4, and it looks like there are 12 tables to seat 50 people. Next. In Oregon, which has no sales tax, Gloria bought 3 notebooks for $1.57 each. Okay, $1.57 times 3. She spent $4.71. Okay. If she paid $5, what's the least amount of US coins that she could get in change? So if she paid $5 and it cost her $4.71 because there's no tax, then that means she's got 29 cents coming back to her. So what's the smallest amount of coins? Well, we would probably take a quarter. That'd be 25 cents. And then we would need 4 pennies. So the total number of coins would be 5 coins, and that would be the least amount that we could do. Next. Another scientific notation. The mass of fluorine atom is 3.16 times 10 to the negative 23rd grams. It's pretty light. What is the mass of 1 billion fluorine atoms? Express your answer in scientific notation to 3 significant figures. Okay, so I'm going to take 3.16 times 10 to the negative 23rd. That's 1 fluorine atom. I want 1 billion of them. 1 billion, if I move this decimal back, is 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 billion is 1 times 10 to the 9th power. So 3.16 times 1 is 3.16. And then we're supposed to add the exponents because we're multiplying. So we end up negative 23 plus 9 ends up being negative 14. So our final answer is 3.16 times 10 to the negative 14. That is 3 significant figures. I have 1, 2, 3 figures there. So that's what they meant by 3 significant figures. Problem 16. A restaurant offers a dinner special in which diners can choose any one of 3 appetizers, any one of 4 entrees, any 2 different side dishes out of 5, and any one of 6 desserts. All right, so we've got the appetizers. There's 3 choices we have. We have the entrees. That is 4 choices. We've got a side dish where we have 5 choices, but we get to pick 2. This is 5 things, but choosing 2 from them. So that's for the side. And then the dessert, we have 6 choices. Okay, so 3 times 4 times 5 pick 2 times 6 is going to be our answer. So now we just need to do 5 pick 2. So if I have 5 items and I want to pick 2 of them, I'm going to pick 2 of them and not pick 3 of them. So that's what 5 pick 2 would look like. So remember in the factorial, this is 5 times 4 times 3 times 2 times 1. This is 3 times 2 times 1. This is 2 times 1. So if I've got 5 times 4 times 3 times 2, I'm not going to worry about the 1. This is 2, and this is 3 times 2. I can cancel out these 2, and then 2 goes into 4 twice. So if I have 5 things, and I'm going to pick 2 of them, there are 10 ways to do that, 5 times 2. So this problem is asking us, what is 3 times 4 times 10 times 6? 3 times 4 is 12. 12 times 6 is 72. 72 times 10 is 720. This problem requires you to understand combinatorics. I will post one of our videos on combinatorics if you've never done this before, and it'll kind of give you a heads up on some of those. We will definitely be practicing these more as we go. All right, next one. Takes 15 machines, 15 minutes to make 500 raviolis. The machine produces raviolis at a steady rate, so it's a constant rate. How long would it take 75 of these machines to make 6,000 raviolis? All right, so I've got a different number of machines, but here's what I could do. I notice that this is 5 times the number of machines that this is. So if I have 75 machines, it would take them 15 minutes to do 5 times the number of raviolis, 2,500 raviolis. So if 15 machines can make 500, then 75 machines would make 2,500. And that's 15 minutes. All right, so now we have the same number of machines to compare here. So now we're going to compare the raviolis and the minutes. So I know in 15 minutes, these 75 machines are going to make 2,500 raviolis. And now we can set up a proportion. I want 6,000 raviolis. And I want to know how many minutes that's going to be. So we got the same number of machines. Now we're comparing minutes to raviolis. 15 minutes is 2,500 raviolis for 75 machines. And then I want 6,000 raviolis, and I want to know how many minutes there are. Now for this problem, if we do cross products and get 2,500 x equals, we don't need to multiply these numbers. In fact, it's almost helpful not to. So I'm just going to write it as 15 times 6,000. My next step would be to divide both sides by 2,500. Remember, we're trying to do these problems as fast as possible, so doing extra math is going to slow us down. So I know that all these are factors, and I can just start reducing them. These two zeros represent 100, so I'm going to take off this 0 and this 0, and that's going to reduce this 0 and this 0. So now I've got 15 times 60, and I've got 25 down here. 25 is 5 times 5. Well, I can reduce 15 and 5 right here, so that becomes 3 and 1. And then 5 goes into 60 12 times. So I have completely reduced my denominator, and now I'm just left with 3 times 12 on top. So our answer is 36 minutes. Next one. 4 chips are distinctly labeled with digits 2, 3, 1, and 7. 1 chip for each digit. 2 chips are drawn at random without replacement and placed in order which they were drawn from left to right to form a 2-digit number. What is the probability that the 2-digit number is a prime number? Okay, I need to find out how many different combinations I can get from this. They're all different numbers, so I'm not going to get any repeats. So there are 4 ways to pick the first chip. And since we're not replacing them, once we've picked one chip, the second chip, there's only 3 ways to choose it. So we only have 12 different combinations to choose from here. That's our denominator. Now we just need to find out what's the probability that we're going to get a prime number. So we need to find out how many prime numbers we can make from this. Let's start with 23. Yes, that's a prime number. I'm going to write them all over here. What about 21? No, that's 3 times 7, so that's not prime. What about 27? No, that's 3 times 9, so that's not prime. Okay, let's move on to the next one. What about 32? No, that's 8 times 4. What about 31? Yes, there's one of them. What about 37? Yeah, that's prime. All right, now let's move on to 1. 12, no, that's not prime. 1, 3, 13, that is prime. 17. Yes, that is prime. Now let's move on to 7. 72. Now that's 9 times 8. 73. That's prime. 71. Yes, that's prime. All right, so I now have 1, 2, 3, 4, 5, 6, 7. 7 prime numbers out of the 12 possible combinations. So we have a 7/12 chance of picking a prime number. Almost there. The letters A, B, and then all the way through Z are equally spaced in order on the number line, with A at 0 and Z at 25. What is the average of the two numbers that are 4 units from the letter M? All right, if A is 0, that's 0. B, C, D, E, F, G, H, I, J, K, L, M. M is the 12th letter, or would be on number 12. So M would be number 12. It wants the average of the two numbers that are 4 units from M. Well, 4 units this way and 4 units this way, they're still going to average out to 12, right? If I add 4 this way and subtract 4 this way, it's still going to average out to 12. So my answer is 12. All right, last one. On a coordinate grid, B is located 8 units below and 2 units to the left of A, which is at 0, 6. What is the length of the segment of AB? Express your answer in simplest radical form. Okay, we don't actually have to graph this one on a coordinate plane. If I know A is here, and I'm going down 8 units, and I'm going to the left 2 units, and that's where B is. Remember, the quickest way to get to 2 points would be a straight line. So I'm looking for this distance from A to B. This is not one of our Pythagorean triples, and that's why it says to leave your answer in simplest radical form, because this is not going to come out to an integer value. So if this is C, we would do A squared plus B squared equals C squared. We use the Pythagorean theorem. So this would be 2 squared plus 8 squared equals C squared. 2 squared is 4. 8 squared is 64. That's 68. And then we would take the square root, and the distance would be the square root of 68. So that's an irrational number. It's not a perfect square. It's not going to come out nice for us. But it does ask for the answer in simplest radical form. Simplest radical form means if this number has any factors that are perfect squares, we need to take them out. So our perfect squares would be like 4, 9, 16, 25, whatever. So are there any factors of 68 that are perfect? Yeah, 4. So we can rewrite this as the square root of 4 times the square root of 17. 17 times 4 is 68. So when we are writing it in simplest radical form, we're going to do this, and then we know that the square root of 4 is actually the number 2. So our final answer in simplest radical form would be 2 root 17. The end. Isn't that a cool story? All right, some of these harder than others, especially if you weren't clear on the Pythagorean theorem and stuff like that. So again, I'm going to put up videos on the Pythagorean theorem, and I'm going to put up videos on combinatorics, so you can start looking at that. You're going to see a lot of those keep popping up. All right, keep mathing hard. I'll see you guys later. Bye-bye.